Lesson 3, factorial notation. So let's consider how many ways the letters in the word movie can be arranged. So there's 5 letters. So if you pick one of them, you've got 5 options. The next spot, one of them's been removed. So you've got 4 options, and then 3, and then 2, and then 1. If you multiply this, you get 120. So in the above example, we had to find the product of 5 times 4 times 3 times 2 times 1. In mathematics, this product is denoted by 5 with an exclamation point, and it's called 5 factorial. In general, n factorial is n and then n minus 1. So if you think like 5, and then what's 5 minus 1? You get 4. What's 5 minus 2? 3. What's 5 minus 3? 2, etc., all the way down to 3, 2, and 1. Factorial notation is only defined for natural numbers. Expressions like -2, that is a integer, and that is a rational number, so no good. So let's evaluate. 8 factorial is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and you get 40,320. All right, 10 factorial over 7 factorial. So if we expand the top part, you'll get 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you expand 7 factorial, you get 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, if you notice on the top part and the bottom part, you've got the same stuff going on there. And if you actually know anything about mathematics, 7 divided by 7 is going to give you 1. And 6 divided by 6 is going to give you 1. 5 divided by 5 is going to give you 1. Okay? So we sometimes say they cancel out. All right, so 1's canceled, 2's canceled, 3's canceled, 4 cancels, 5 cancels, 6 cancels, and the 7 cancels. All right, well, that's a little bit too much information to erase. So what we're going to do is we're going to leave that part as 7 factorial, and then leave that as 7 factorial. And then we can show that those parts will, in fact, simplify to 1, not cancel. They'll simplify to 1. So 10 times 9 times 8 is 720. All right, 355 factorial divided by 353 factorial. If you expand this, you get 355 times 354 times 353 factorial over 353 factorial, and those will simplify to 1. So you get 355 times 354, which, a quick mental math, just kidding, using my calculator, 125,670. What happens when you get like weird things like 37 factorial over 33 factorial and 4 factorial? What's going on here? All right, well, let's just expand the top part here. And you're going to get 37 times 36 times 35 times 34 times 33 factorial. And on the bottom, we already have 33 factorial. We also have this 4 factorial. Well, which parts can simplify? Well, this 33 factorial and that 33 factorial. So this simplifies a little bit farther. Okay, and if you multiply the top numbers, 37 times 36, etc., you're going to get 158, 5080, and the bottom goes to 24. And then further simplifying goes to 66,045. So let's simplify the following expressions. Well, if you notice that, see how this is 1 less? So that still kind of follows this idea, that it's all going to be 1 less. But what's your first term in this case? Your first term is n plus 3. So n plus 3, and we're going to call it factorial, okay, because the pattern continues. All right, n factorial over n minus 2 factorial. So the top part, you're going to get n, and what's 1 less than n? N minus 1. And 1 less than that, n minus 2, n minus 3, etc. Okay? And the bottom part is n minus 2 factorial. So you start at n minus 2, and then you go n minus 3, and so on. So that part can simplify. So you're left with n and n minus 1. Now you could leave it like that. I would expand n squared minus n. That's what we're going to leave it as. Okie dokie schmokies. N plus 3 factorial over n factorial. So the top part you're getting n plus 3. 1 less than that is n plus 2. 1 less than that is n plus 1. And then we get to n factorial. And that is the denominator. Well, that, my friends, will simplify. So you're left with the top part there, which is n plus 3, n plus 2, n plus 1. All right, so if you expand your second terms here, you'll get n squared plus n plus 2n. So the middle part goes to plus 3n. And then your last part goes to plus 2. And then again, if you expand all this, you'll make it all the way down to n cubed plus 6n squared plus 11n plus 6. I didn't show, I skipped a step here. And the step was expanding all these terms. All right, n factorial over n and n minus 1 factorial. So for this one here, the top part is going to go to n and then n minus 1 factorial and keep going. And the bottom part here, we've already got n and n minus 1 factorial. So just all I've done is expanded that a little bit, but you'll notice that the whole thing simplifies to 1. Right, n minus 2 factorial over n minus 5 factorial. So n minus 2 factorial is then going to go to n minus 2, n minus 3, n minus 4, and n minus 5 factorial. And there's our denominator. So that's going to simplify. And then we're left with n minus 2, n minus 3, and n minus 4. Okay. So let's expand the second terms here. So n minus 2, n times n is n squared, n times negative 4 is negative 4n, negative 3 times n is negative 3n, so negative 4, negative 3, negative 7n, plus 12. And then again, if you expand, you're going to get n cubed minus 7n squared plus 12n minus 2n squared plus 14n minus 24, which all simplifies down to n cubed minus 9n squared plus 26n minus 24. All right, n plus 2 factorial over n plus 4 factorial. All right, the bottom here, remember, becomes 1 less. So n plus 4 is the first term, n plus 3, 1 less, and then n plus 2 factorial. Well, now we can see what simplifies out. Now be careful. A common error, well, students will go, okay, well, everything canceled out, so I'm left with n plus 4, n plus 3. You are, but you're also left as that in the denominator with a numerator of 1. So do not forget about that 1. And if you expand the denominator, you'll get n squared plus 7n plus 12. Okie dokie, we're going to use this factorial. We're going to solve for n. So let's figure out something here. The numerator is n minus 1, n minus 2 factorial. The denominator is already n minus 2 factorial. So that will simplify to 1. So you're going to be left with and if you expand this part here, you'll get n squared minus n equals 90. And how do we solve this now? Like, we've got this variable. Well, what we'll do is we'll subtract 90 from each side, and you're going to get n squared minus n minus 90. And if you factor this, you're going to get n minus 10 and n plus 9 equaling 0. Well, how do we make this statement true? If you put in a positive 10 or a negative 9, you will get solutions to that quadratic. However, if we go back to the beginning of the lesson, you can't put a negative number as a factorial. It only works for natural numbers, not integers, not rational numbers. So what we can do is